very pleased to introduce Lewis Prescott, who is an experienced QA lead at Seracare, how you say it. I'm sure Lewis will correct me. One of Europe's fastest growing companies, he says. Having worked across different industries, including healthcare, non-profit, retail, and prop tech. He's also a course author on Test Automation University and Udemy. Sharing his knowledge is a passion of his. Now, Lewis is here to talk about contract testing and an introduction. So, Lewis, over to you, mate.
Can you hear me okay?
Yeah.
Is there a bit of reverb?
There is reverb, yes. Who else has got their mic on?
It's the jabber in the room.
I can't see anyone. Just say something again, Lewis, please.
Hello? Yeah. One sec, let me turn my sound off in my room. He's already on mute.
Yeah, I still hear it. I guess you hear it too. I think we're just waiting for Lewis. I think maybe the problem's at his end to resolve the...
Is that better?
It's excellent. You've got it. Okay, go for it.
Awesome. Technology when you're meant to be remote, but you're actually at the conference. Cool. So I'm going to be talking about contract testing today. So a little bit about me. I'm QA lead at Seracare, which is a home care technology company who work, we're based in the UK and we work in the care industry. So we're developing technology for that industry. It's like a technology company, but we work in a very non-tech industry. So there's lots of challenges around that as well. But yeah, very interesting place to be. Outside of that, also, I have a course on Test Automation University. I've done some workshops with Ministry of Testing, and also I've appeared on a few podcasts. I've got one of my own as well. So that's a little bit about me, and often I talk about contract testing. It's something that I really enjoy doing. So primarily, why would you get involved in contract testing? I found this article, which was really interesting, which explored the popularity of it. And as you can see, the red line is like monolith applications and the blue line is microservices. And so we're getting to the point where they're kind of on an equal in terms of popularity. Obviously, you've got legacy systems which will be around for a long time, but yeah, obviously, the increase in popularity has increased people's experience with contract testing. And this article title says that it's the new unit testing, which I think is a bit of a bold statement, but hopefully within the talk, you can see the benefits and see the comparisons as well. So we compare the two of how we would go about testing. Traditionally, you had a monolith application. You've got multiple domains within that monolith. So if you're hitting an API, for example, and they're pulling in different data from different areas, then your API test would actually be testing lots of different domains. Whereas in microservices, we've split out all of those so that hopefully you have independent services which purely have their own domain and control their own data. So you can actually test the specific domain through a contract or through that API individually. And so if you imagine whether you wanted to test the scenario on the left where you've got all of those domains, how would you go about testing those in a microservices environment? There would be lots of things that you need to consider. So one of the main questions that I get is, what is contract testing? And it is quite hard to comprehend when you come from the traditional integration testing, and you think, wait a minute, there's two different parts of it. There's you have to completely come about it in a different way. So the way that I describe it is we're flipping integration testing upside down. So when I say upside down, what I mean is that the person who's creating the test is not actually the person who is involved, right? So the consumer, the person who is using the API is actually the person that comes up with the tests. So that's why I say it's about flipping it upside down. So I've got a little interaction. You could go on whatever device you have available to you, go to menti.com and put in this code, or you can scan the QR code. There's a couple of questions about integration tests, issues you have with integration environments. So just answer those questions, and then we'll have a look at the results in a minute. So as we can see, no one has actually put never in how often do you find issues in the integration environment. So most people have experienced that there will be times where you developed it and all looks good from a unit test perspective, and then you get to the integration environment. This particularly becomes very complicated when you've got distributed teams, when you've got distributed microservices, when you've got third-party applications as well, and it becomes very, very challenging to keep your environments up to date. So the other question was around the stability of the environment. So when you're doing your integration test, for example, you may rely on that environment, right, to run your tests. And when it's not stable, that becomes very frustrating, or you have to implement a retry. Or if you're spinning up the environment as part of your pipeline, for example, if you have the ability to do that, then that becomes still very expensive from a maintenance perspective. You have to make sure that you're keeping that all of those environments up to date, all of those configuration files up to date, and then also you have to run it as part of the pipeline, which costs money, right? So as you can see, there are challenges to working with integration tests, and that's where contract testing comes in. And to highlight some of the issues that I've had in my experience, one of those being we had two versions of our API. We were supporting two versions, one for our legacy system who had 6 monthly releases. So they could upgrade to the version 2, but it would take 6 months. So we weren't going to wait for that, obviously, to develop new features. So, or retire data, which was causing bad data. So we made a change to our API contract, but that affected both versions of the API. So we were making a change because we were getting bad data in our database, and so we wanted to prevent that from happening. So we changed one field from being optional to being mandatory. So we wanted to make sure that the data didn't get in without this specific data. So we made that mandatory. But obviously V1, who has a 6 month cycle, this was causing their application to put their processing into a dead letter queue. So they were just trying to process this, and it just kept on ending up in the dead letter queue. So obviously we had to revert the change, make the change only to the V2 model, which impacted the web app and the mobile app, and make sure that we didn't impact V1. So now we had two versions of our API that were different and were causing different issues. And we're still getting the bad data from V1 because they can update theirs from their side. And so these are one of the scenarios where you can have those kind of issues, especially when you're supporting multiple versions of the API. It becomes very difficult to maintain. Another issue that we had, which crept into our code, was that we had this serialization of objects before we returned our responses. And what this piece of code is doing is it's saying if we have any null values, strip them out of the response, because who cares about nulls, right? If it's null, then why would you care? But it turns out one of the teams that was consuming this API did care about it, because for their front end application, if it was null, then they would do something different on the front end, whether the value was within the response. So you can't assume that people aren't using things, and assumptions is a huge part of how we get into these situations in the first place. So yeah, just a couple of scenarios to explain how these things can get into this state. So I reached out to the community, and we have another example of someone else of how they had contract issues as well. Enumerations, like lists of things, which can cause issues. The format of responses, again, someone just making simple syntax changes, changing to typos and things like that obviously have detrimental impacts. And then one of the huge things about contract testing is being too specific with what you accept. And so through contracts, you can say, we accept this type, we accept these different types, rather than being very specific with what you accept. And then if you need to make a change to a contract, then you have to change the API contract, which then will cause downstream impact. So Martin Fowler has a good description of what a contract test is. An integration contract test is a test at the boundary of an external service, verifying that it meets the contract expected by a consuming service. So what this means is that we are not doing that full integration. We're never actually communicating with the integration. We are just saying, at this boundary, this is what we agreed, and this is what our contract is. And so you can test at that boundary, and then the other side can then look at that contract and they can say, okay, we conform with this boundary as well. And so then both boundaries are verified without you having to spin up an integration environment or have any integration tests. So one of the conversations that we have around APIs is to do with setting up those contracts and how we're going to test them. So how do we have those conversations about what issues might happen when we're testing? So scenarios that I've been in the past, we have a wiki page, or we have Swagger documentation, which we create before we develop the API. So then we share that with the other team and we go, okay, fine, both teams are conforming with this contract. No worries, everything will develop it as expected and we'll have no problems. We all know that that's often not the case. And so how are we going to build stuff without it being ready? We've got front-end developers, we've got back-end developers, and we want them to work in parallel. Otherwise, the length of the project is going to be much longer. Okay, they can use mocks and stubs, which conform with their initial contract, and then we can push to the integration environment and we can check that they've implemented it as we expected. As you know, things change as you're developing, and contract changes happen all the time. So that's another challenge. Another area that people have problems with is often the integration environment can get quite bloated. Say you've got lots of teams working on an integration environment, there's gates to get into that environment because you can't stop other people working, you can't break other applications. So there's gates, and so okay, so this team is going to set up an environment that just has their microservice in it and stubs out all the other services. So then you've now got another environment. And then, so we've got our clients now, we've integrated with them successfully. How are we going to make changes to that? As I said before, with the data, with the bad data that we're getting, how do we make changes safely to that? So we could implement versioning. How do we make sure that we are supporting? Who's supporting which version, and how do we know which versions we can retire without causing any issues? So this is where consumer-driven contracts come in. So there's now a concept of bidirectional contract testing. So if you have existing applications which don't have contracts, then you can retrospectively add them. But consumer-driven is kind of where the idea first came about, where the consumer is driving those contracts. So they are the ones that create those scenarios, and then the API is the one that runs those scenarios to check that they've built the right thing. And one of the things that I think is truly one of the biggest benefits of contract testing is that communication, that ability to have a conversation about your integrations, and you can all point to this this contract and say, okay, these are the changes that we want to make. These we're going to build this. We need this data, and it just enables you to have those conversations. Whereas when you're having those conversations with static data, with a Confluence document, with a Word document, with Swagger documentation that's built before you build your application, or Swagger documentation that's generated after, you can't obviously worry about that because that's generated from the code. So that only confirms what the code has done. This stuff goes out of date, right? Like the point at which you're looking at that documentation is not necessarily the truth. And so this is one of the fundamental areas, and I think this comes across lots of different challenges that we have in building software, is just having that conversation. And so this tool absolutely helps with that. So how does it work in practice? So what's happening is the consumer, who is the application, another API service, or an app of some sort, they are creating the contract and they are setting the request and the expected response. Once that contract has been created, they are storing that in a pack broker. They are storing that in a common place, which can be accessed then by the provider. Get rid of this. Then the provider here, the API service who creates the API, they can then just replay that contract. They're not making any changes to the contract. They're not serializing it on their side. They're not doing anything with it. All they do is replay it. There may be some conditions that they need to set up. For example, there may be a token that they need to get. There may be some data they need to set up before they can run their contract. But ultimately, they're just replaying exactly what the consumer provided them. And then at this point, then the consumer, the application, can then request, should point to the pack broker really, request from the broker, can I deploy my application? Has the provider, the API service, verified that my contract conforms with what has been built? And so at this point, you can then be confident that you can release your software without relying on any integration. And this is where a tool called Pact comes in. So I use Pact, but there are other tools out there. Pact just allows you the framework, and it has all of the kind of built-in verifications. It has plugins and stuff like that, which you can use to generate your contracts and verify. So it sits right next to the code base. So anytime, for example, you make a change to the API, then it will create a new contract. And so that's one of the big benefits of it. You don't have to rely on someone saying, okay, your contract has changed. At the consumer level, it mocks the response. So there's no dependencies, and then it makes a request to the server as you would do normally. It just intercepts it, but the request is not changed in any way. There's no differences. Once the results are in, this is the Packflow mascot. It will then be published. You only publish, obviously, your contracts when you in your CI pipeline, like when this is actually going to be released. You only publish them then, and or you could publish it as part of your pull request, for example, and then you could say to the other team, we're going to make this change, please point to this specific version of the contract to make sure that we're going to release successfully. The pack file is then available so that the provider test, the API, can trigger the test and run the verifications. All the verifications are set up at the consumer side, so there's no nothing else to do. So what are the kind of benefits of it? So as we mentioned, it runs independently. There's no dependencies. It gives you fast feedback. We're just pulling down a contract file, so there's no kind of steps to go through. You're just replaying an API request. It's stable because it sits next to the code, so there's no nothing that you need to change once you've developed the test. They're easy to maintain because it's just simply a contract. There's no moving parts, and ultimately, this is what we want to achieve: is confidence in our release process. We want to make sure when we push to our integration environment, before we go to production, all the microservices are working as expected. And that's ultimately what we want to achieve, the confidence. And also there's some cons. There's setup costs, there's duplication of code, and you have to have packed tests alongside your unit tests. And there's stuff to try and alleviate that pain now with bidirectional, but ultimately there is some duplication there, and this doesn't replace integration testing. So you still need to have those integration tests to be able to verify the configuration is correct in your environment. You need to make sure that the API service is available, which contract testing won't do. So that's slides shouldn't be in there. So I mentioned a bit about bidirectional. So bidirectional is now the ability for you to have your existing tests and your existing mocks, and then you turn them into contracts. So instead of having that duplication, having that that additional overload of adding more tests, you can now use bidirectional, which has integrations with things like Cypress, WireMock, mock service worker. So those kind of things which you already have mocks, they can then be turned into contracts. And then on the provider side, instead of writing tests which verify the tests, the pack test, you are verifying the Swagger API documentation or Open API documentation. So you are then verifying two sides of the same thing. And how this is a diagram of what I've just explained, but basically you're just turning your initial mocks into your existing mocks into contracts. You're putting them in the same place in Packflow, or you've got your own pack broker, and then you're using your own tools again to verify the contracts. So effectively, you're doing the same thing, just with existing tools that you already have. So one of the hardest things to do with contract testing is to get buy-in from your teams, and to have the time and space to be able to do this as part of the project. The best time to do it, right, is when you're building the thing in the first place. But if you need more convincing, then Pact has some great documentation on it. There's also some great webinars out there. Singular, who's like a consultancy, recently did one where they showed the benefits and the costs of implementing contract testing and the benefits that gave. There's also a blog post which talks about the fallacy of integration tests, and talks about how scaling your contract tests is massively better in terms of time and scalability, because there's no kind of scaling cost to a mock. It just exists. Whereas obviously when you're running your end-to-end tests or your integration tests, you've got the scaling cost of the environment. So yes, if you need more convincing, go here or check out those things. So I think we're open to questions now. If we've got questions on the call or anywhere else.
Thanks, Lewis. Yeah, please put your questions on Slido if you can. There's usually a delay, Lewis, so I'll probably have a little conversation with you while that happens.
Cool.
Thanks ever so much for that. It's great stuff. I think it was interesting when you did the survey. I didn't realize you were going to do a survey. I mean, my experience, every time any software goes into from a disintegrated situation to an integrated at some level situation, there are problems. Mm-hmm. And my kind of, I don't know what, the symptom of poor integration is that if that's a symptom, the problem is often that there's not communication between people in the developers in particular, but within the team. I mean, what do you think? I mean, how could you make suggestions about how contract testing could improve that situation? Is that the purpose of contract testing, perhaps, at one level?
Yeah, definitely. I think that is one of the biggest wins that you get out of it, is the communication. Because often especially when you're working in like squads, or you're working in areas where you're siloed, right? Like, it's only the nature of working in a team, you automatically have biases of, okay, when we go to the integration environment, ours is going to work perfectly, and then it's going to be someone else's problem that caused it. It's just the nature of human nature. Whereas the ability to have something which allows you to start a conversation, like, that's one of the reasons why we have like API documentation and stuff like that, is so that we can have somewhere to go and start that conversation. So yeah, for me, the communication side of things is really important, and something that you get out of the box with this. It's not something that you inherently think about, right, when you're when you think about it, when you're building your software, right, you need to go and communicate with that team, but you don't think about what tools can help you communicate with that team. You just go and communicate with them. But actually, this is something that really helps with that.
I mean, I didn't see every moment of your talk, I'm afraid, but so I might be asking a question you've already answered. But what's the format of the contracts? Is it something that could be in a range of different domain-specific languages, if that's the game we're in,
Yeah.
or is it just a JSON definition, or what's the format of these things typically?
Yeah, so the contract is always output in the same format. It's always output in a JSON format, which has the specific request, response. You can even use it in like messaging, so it'll just have the body of the message in there. It's always output in the same format, but you write the test in whatever language that you're developing your software in.
Okay.
So there's a wrapper around a Ruby implementation, which has all the verification logic inside it, but ultimately you write the test alongside the code. So whatever domain language you're using, that's where you write the test.
Yeah. I've got a question. I mean, it's beginning to come in now. So anonymous, it would help me if I had an example of a contract test and how it differs from an API test. I mean, is that a question that's easy to answer, or is that like, how long is a piece of string? What do you think?
Yeah. No, if you go to Packflow's website, they have like a university section, which has a tutorial in there. So I would recommend going there and seeing it in action. Very hard to explain the technical side of things. But ultimately, the differences between your API test and the contract test is the contract is not hitting the integrations, right? The integration doesn't exist in your API, in your contract test. And so you're just testing the contract, you're testing the JSON, right? Like whatever the request is that you want to send is in the contract, and whatever the response you expect is in the contract, with the types of the data, all of that kind of stuff configured inside it. So you're not verifying the actual response, you're verifying how you built it, the contract you came up with when you built it.
So, I mean, am I right in thinking, I'm not as familiar as I should be with this, so I'm trying to understand, honestly. Are your contracts describing the internal behavior of the services themselves, or are they literally just looking at it from the API perspective? So it's a bit like, compare it with a functional test that a hands-on tester would like. Are you just looking at the user interface, the API itself, or are you looking at functionality that you know is churning away in the background? I mean, is that a stupid question, or?
No, it's a very good question. So because the contract is created by the user, like the consumer, the application, the other API service, they don't have any insight into the internals, right? All they have is, this is how I want to interact with you. So it comes from the consumer's perspective. So they're going to send a request and say, this is the request that I generated, and this is what I want in response. So they don't have any idea of the internals of how the response comes about, or the request gets consumed. So it's just the API request and response. That's the only thing that is shared. The rest of it is not really for concern.
Okay, but so for example, if the requirement was to deliver the sum of two numbers, I mean, being very simplistic, I supply two numbers, I expect the sum of the two numbers back, so I know it's going to do some addition. So the functionality is described or exampled in the contract itself.
Yeah, but we don't care about the functionality.
No,
All
okay.
we care about
Okay.
is the what is returned. Like if it's a sum, right, and we expect an integer to come back.
Yeah.
And that's all we care about.
Okay. Okay. I'm with you. I just wanted to be sure I understood.
Yeah,
So.
it's not for testing functionality. You would have that at your unit test level to test the logic, and then if you wanted to test how that is rendered, how the response is rendered functional wise, say I enter 2 + 2 on the calculator and I get 4, then that's your a different test.
Cool. Okay. Got one from Anonymous, I'm afraid. Would this work in an event-driven architecture with multiple microservices?
Yes. So messaging or events is something that is supported because what you're doing, right, is your contract is your event. So the event that is published is your how the consumer publishes it, and then whoever is consuming the event is the one that reads it, but the provider is the one that publishes the event. Then they're still contracts, right? You still need them to be in the right format, to have the right data, so then you can continue with the rest of the processing which happens. And as you say, it may be multiple microservices which have multiple events. So you'd have multiple contracts, right? But they're all independent contracts. So you would have, multiple contracts to test that one specific journey.
Do you think, I mean, one of the criticisms of traditional developer unit testing is that they test at a component level and they're fairly confident the components work, but when integrated, the components don't work in synchrony, whatever that means, in an integrated way.
Yeah.
So does contract testing, do you think, eliminate the need for end-to-end testing? So if there's, say, a chain of service calls, I know you're smiling. if there's a chain of service calls, what you really want to know is whether the chain of service calls work as much as each individual service call works. I mean, what's your view on that? I mean, are we getting closer to avoiding long-winded end-to-end tests, or what do you think?
Yeah, a year ago I would have said a different answer, but I think the beauty of this, the way of doing this contract boundary driven, is the scalability of it. Is if you have all of your consumers in contracts verifying your API service against multiple versions, against multiple implementations of services, your whole system's covered within this scenario, then your end-to-end test should work, right? Like there's no reason why they wouldn't work. You do still need that integrated test though, because your infrastructure is separate, right, from your contract. So you still need something to test that the infrastructure supports your service. So that still needs to exist, and often that will exist in an end-to-end scenario, because you might as well have one test which tests the full journey rather than having multiple tests.
Yeah.
So my answer is yes, it should solve the problem of having fully integrated environments, but where you do that end-to-end journey is maybe the question.
It's not a very fair question, I know, because it's so dependent on how these things are constructed, designed and constructed, I think. So have you got any other thoughts just to close? Because I'm rapidly running out of time now with you. So anything else you'd like to just add to what you said?
No, I think if you want to know more, just feel free to reach out to me on LinkedIn or on Twitter, if that still exists in a week's time. But yeah, feel free to ask more questions. I think today was only an intro. There's still plenty more to learn, and yeah, go and check out more resources around it.
Great stuff. Thanks, Lewis.